Hello and welcome back to another homework explanation for homework 1.6. We're starting the retrieval of 1.6. Find the coordinates of the vertices of the new quadrilateral formed if you reflect quadrilateral ABCD over the given line. To do that, we first need to know the slope of the line of reflection. Line of reflection has a slope of up 1, 2 over 1. Slope of 2, basically. Now, we get the reciprocal. Opposite reciprocal slope, which is the perpendicular slope, which is negative 1/2. Now, if I start at A and start counting down 1, forward 2, that is not going to take me across the reflection line. So I actually have to go up 1, backwards 2, because up 1, positive 1, over these two numbers equal each other. You can go down and forward, or you can go up and backward. It's the same thing. And you can prove that to yourself. Down, forward, up, backward. Now, I also have to be equally distant on the other side of the line of reflection. From A to the line of reflection is the same distance as the line of reflection to A prime, along that slope count. And it's so nice. B is like right in line. 2 more counts over. It's like they were trying to be nice to us. There we go. Some sort of square. Now, this one is B prime. This one is C prime. This one is D prime. Stayed close. But then they want to know the XY coordinates. A prime is at 1, 8. D prime is at negative 1, 4. C prime is at negative 5, 6. Finally back up to B prime. 10, negative 3, 10. Sweet. Okay, now into the real homework. What is the smallest fraction of a circle that the wagon wheel needs to turn in order to appear the very same as it does now? How many degrees of rotation would that be? Well, if it went all the way around, obviously that's 360. But it doesn't need to go all the way around. It only needs to go this far. Well, how far is that? Well, it's 1, 2, 3, 4, 5, 6, 7, 8. 1/8 of the way. Okay, grab a calculator. That's the answer. So count the sections. Divide 360 by the sections. You got it. No problem. Lines of symmetry. If it's odd, this is what you're supposed to learn in the lesson. If it's odd, the lines of symmetry go through a corner and the opposite middle of the opposite side. Well, here's a corner, and the line of symmetry is going to go through it and to the opposite side. And here's a corner, so the line of symmetry is going to go through it and to the opposite side. And that's a total of 3. If it's even, something different happens. You have half the lines go through a corner and the opposite corner, and half the lines go through a middle of a side and the opposite middle of the side. Because even-sided regular polygons are even-sided, they have matches. Everything matches, so you can divide it up 2 different kinds of ways and it'll always match side to side. But odd ones don't evenly match, so you have to split the last side. Like this side can match that side can match that side, but the 5th side has to match itself always. So if you come down through a corner, you have to split that side. One way to understand this, though, is if you rotate, here we go. Now it looks just like it did before, and I split from the top to the bottom. Some people have a hard time seeing the other splits, except for left and right. Our brain is really good at left and right, probably because when we look at each other, our eyes are left and right, our ears are left and right. We're symmetrical left and right, but it's harder to see symmetrical at a 45-degree angle like that. Oops. There we go. Okay, fill that out. Now this is different. Draw the diagonals in each regular polygon. Is the pattern linear, exponential, or neither? How do you know? Attempt to find an expression for the number of diagonals inside a polygon. A diagonal goes from corner to corner, not on an edge. Well, that's impossible in a triangle. All the corner to corners are edges, so 0 diagonals. In a square, you can go from that corner to that corner, not on an edge. You can go to that corner to that corner, not on an edge. That's 2. Pentagon is where it gets interesting. Now, these are not lines of symmetry. These are diagonals. These are lines of symmetry and diagonals. These are diagonals, but not lines of symmetry. But from every corner, there's 2 of them. But that doesn't mean you can just multiply by 5 by 2 because you'll be double counting. So see if you can figure out a way to calculate the diagonals. If I give you some number, you tell me the diagonals. What's a rule? And n sides. I give you n sides of a regular polygon. Like I say 20 sides. Then you tell me the diagonals on the 20 sides. Polygon. Okay. That should be fun. What are the angles of rotation for a 20gon? Well, these are like the problems at the very beginning. You have 20 sections. This should say regular 20gon. So you can list them all out, or say, or just figure out the smallest angle of rotation that will carry it on to it symmetrically. Start with 360 degrees, divide it up. Same thing for the 15gon. Now this is more interesting. Now you are given the angle of rotation. You have to figure out how many sides it has. Well, remember when we did like 360 divided by the sides, we'll call n. Well, now we know that equals 18 times both sides by n. Divide both sides by 18 degrees. And there's your answer. Notice how it ends up just being the exact same situation. You take 360 degrees, divide by, instead of dividing by the sides, now you divide by the degrees, and it'll spit out the sides. So you don't actually have to do the algebra. You can just take the 360 degrees and divide by the degrees provided, and that'll tell you. For the Go, it says, use tools to make your work precise. So let's see some rulers. Yes, but this one I think you could probably do. Let's see. 1, 2, 3. Yeah, this one you can do without a ruler, but this one, the slope is 1, 2, 3, 4, 5, 4. The slope is -4, but if you count out the opposite reciprocal slope, it's going to be confusing. So you got to actually measure this with a ruler and then go that much further over here, so it'll be somewhere over there. Don't forget to draw the corresponding line first so you know where to go along. Okay, I think that's it. Yep, reflect those across. The last thing would be these, which to do these, you draw the corresponding line, figure out its slope, then do the opposite reciprocal, and then split that line. All right, have fun.